Hello everyone, myself Dr. Divya, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. So today we will discuss the topic of electrochemistry, which is very important in engineering, that will give us the idea of electrochemical reactions, and that will also help in understanding the corrosion techniques afterwards. So here are the topics: introduction to electrochemistry, then conductors, what are the types of conductors, then electrochemical cells, what are the electrochemical cells or the devices that are used to convert the chemical energy to electrical energy or electrical energy to chemical energy, then electrode potential, then standard electrode potential, then determination of standard electrode potential, then how do we predict the spontaneity of reaction. So all these topics will be covered today. And so here is the introduction. Before jumping to the main topic, we will understand what is electrochemistry. So electrochemistry is a branch of chemistry which deals with the transformation of electrical energy into chemical energy, transformation of electrical energy into chemical energy, and also chemical energy into electrical energy. So both the ways there is a transformation of energy. So as we understand from the basics, energy can neither be destroyed nor created, it only can be transformed. So that is what we are going to understand in this electrochemistry topic. So there are some laws of electrochemistry that is nothing but Faraday's laws that forms the basis for electrolysis or electrosynthesis. Electrolysis or electrosynthesis. So we will understand in deep how these are going to help us in engineering. So then the knowledge of this electrochemistry is immense importance to study the causes of destruction of materials. So we have to understand the main electrochemical reactions or redox reactions before we understand what is corrosion. So this is the first chapter, and in electrochemistry there are two types of processes. There are electrolysis and electromotive process. Electrolysis and electromotive processes. These both are interrelated. So what is electrolysis? We will see what is electrolysis. Electrolysis is electrical energy causing some chemical reaction. So electrical energy will impart some chemical reaction in the solution or the aqueous solution. So that is nothing but electrolysis, and the container or the cell is called as electrolytic cell. That is called as electrolytic cell. Then what is electromotive process? Electromotive process, there is some chemical reactions that are taking place producing electrical reaction or the electrical energy. So that chemical reaction will give us electrical energy. So this electromotive is nothing but electron in motion. So electron in motion or flow of electrons will give us electrical energy. So before understanding the electrochemistry, we have to understand what are conductors. Whereas we know there are some conducting materials that are used. So the substances that allow passage of electric current, the substances that allow passage of electric current are called conductors. So conductors, why are they? How are these conductors formed? There are several metals like copper, gold, and other metals or graphite. So how are they formed? They are like based on the valence band theory, where as we see here, there is valence band and the conduction band, valence band and the conduction band. So there is no gap between the valence and conduction band. So it is easy for the electrons to jump to the conduction band with some applied voltage or in free state. So that is how they are allowing the electrons to jump and causing the electric current. So there are mainly two types of conductors. Two types of conductors: metallic conductors and electrolytic conductors. Metallic conductors and electrolytic conductors. What are metallic conductors? So these metallic conductors are metals. Metallic conductors are nothing but metals that conduct electricity through electrons. So metallic conductors conduct electricity through electrons. So these are called metallic conductors. So what are electrolytic conductors? Electrolytic conductors are substances that allow passage of electricity through ions or their molten states. So nothing but, for example, sodium chloride in the molten state. This is an aqueous solution wherein sodium chloride is present in aqueous state. So here the sodium plus ions and chloride minus ions are the ions that help in conducting the electricity. So these are called as electrolytic conductors, and this property is called electrolytic conductance. So what are the main differences between metallic conductors and electrolytic conductors? So the conductance that occur due to migration of electrons is called metallic conductor. And the main importance difference is the ions, the migration of ions like sodium and chloride ions that help in conducting electricity forms the electrolytic conductor. So the examples are acids and bases. Then the other difference is the passage of electron due to electron flow and the passage of electron due to ionic flow. So there are no reactions that will be taking place in the metallic conductor because metals as such have some electrons to move. So there are no reactions taking place. However, in electrolytic conductor, there are some chemical reactions that are taking place and help in conducting electricity. So there are free electrons responsible for the electrical conduction. So in metals, the electrons are free, so that will be helping in conducting the electricity. In ionic conductors like electrolytic conductors, free ions will be produced that will help in conducting the electricity. So therefore, there is no mass transfer in the metals. So no such mass transfer is taking place. However, mass is transferred in the electrolytic conductor. So the ions are nothing but the transfer of mass. So then with the increase, there is some factor like temperature wherein as the increase in temperature for the metals, there is an increase in the resistance. So the resistance increases, so the conductance decreases. Whereas it is inverse in the case of electrolytic conductor. That is, with increase in temperature, the resistance decreases and the conductance increase. So electrolytes, so to understand further the electrolytic conductance, we should understand what are the electrolytes that are used and classification. There are basically two types of electrolytes. There are strong electrolytes and weak electrolytes. Strong electrolytes and weak electrolytes. What are electrolytes in the sense? Like the salt is dissolved in a solution. So when the salt is dissolved in solution, for example NaCl, so an NaCl is dissolved in solution, there is scope for dissociation of ions. So this dissociation of ions takes place as Na plus and Cl minus. So the electrolytes which completely dissociate in all solution at all concentrations. So at all concentrations, the electrolyte, that is the aqueous state of salt, will dissociate at all concentrations. That will form strong electrolytes that will give a high conductance also. So these are called strong electrolytes, and examples are sodium chloride, HCl and NaOH. These are strong acid and bases that also forms the strong electrolytes. Then what about weak electrolytes? So weak electrolytes are the electrolyte that partially dissociates at moderate concentration. So at moderate concentration, the electrolyte dissociates partially. So they will conduct a lower capacitance. They have lower conductance, and therefore they form dissociate only to some extent, even at higher dilutions. When the dilution increases, the dissociation also should increase. However, there is small only the weak electrolytes dissociate only to some extent. Therefore, they are called weak electrolytes. Examples are acetic acid, ammonium hydroxide, sparingly soluble salts like AgCl, then silver bromide, silver iodide, then barium sulfate, lead sulfate, etc. So these are some of the weak electrolytes. So electrochemistry has basic reactions that are going on. So there are some devices or cells that will help in conversion of these reactions. So the devices that converts the electrical energy into chemical energy or chemical energy to electrical energy are called electrochemical cells. So there are two basic reactions that are going on in the electrochemistry that are called redox reactions, like oxidation and reduction. Oxidation is loss of electrons and reduction is gain of electrons. So these two reactions takes place simultaneously in any electrochemical cell. So this conversion of energy occurs through these cells. So what are those cells? Electrochemical cells, which is also called as galvanic cells, voltaic cells, etc. And the other one is the electrolytic cells. So in electrochemical cells, there is change in chemical state and no change of matter. So in electrochemical cells, there is change in chemical state and no change in matter. And there are other type of cells in electrochemical cells that are called concentration cells. Concentration cells are having different concentration of same electrolyte or different electrolyte. So that will have physical change transfer in matter. So we will see in detail how these are being used in applications also. So for example, our biological system has some redox reactions going on. So they are applied in biological systems also. And for example, the other application is the batteries or cells, wherein the oxidation reduction reactions are taking place during discharge and charging process. So what are galvanic cells or voltaic cells? Galvanic cells or voltaic cells are also called as electrochemical cells that converts the chemical energy into electrical energy. So chemical energy is already present in a compound, chemical compound that will be converted to electrical energy during usage. So for example, these are the examples like batteries, which are like dry cells, and this occurs due to spontaneous reaction of the cell. So spontaneous chemical reaction will help in converting the chemical energy into electrical energy during their usage. So then what are electrolytic cells? Electrolytic cells are devices that convert electrical energy into chemical energy. Electrical energy into chemical energy. So these require some potential to be applied, or electrical energy, nothing but electrical energy that will be helping into converting into chemical energy. So this is non-spontaneous reaction. Because it is non-spontaneous reaction, we need some energy to be applied before the reaction is taking place. So examples are molten NaCl, electrolysis of molten NaCl, then recharge process of lead acid battery. So recharge process of lead acid battery. So in this, we understood the what are galvanic or the electrolytic cells. So there are different types of galvanic or voltaic cells. So there are three types, like primary cells, secondary cells, and concentration cells. So what are primary cells? Primary cells, these serve as a source of energy only as long as the active chemical species is present in the cell. It means it has some chemical compound that is already present in the cell. So it can be used as long as the chemical compound is active. And these cell reactions are irreversible. So after usage, we have to dispose them. So these are designated only for single discharge and cannot be charged again. So for example, dry cell, zinc mercury oxide cell, or zinc silver oxide cells. These have some applications in our daily usage, whereas we use in our TV remotes or the calculators. The cells are being used for toys, children toys, etc. So once we use it, we have to dispose them. Then secondary cells. Secondary cells are chargeable and can be used again and again. It means they can be recharged. The reaction is reversible. So the cell reactions are reversible. Charging and discharging takes place. So during discharge, it behaves as an voltaic cell wherein chemical energy is converted to electrical energy, and during charging, electrolytic cell where electrical energy is converted to chemical energy. It means during charging we apply current, so that is nothing but electric current where electrical energy we are giving. So this electrical energy is converted to chemical energy that is stored in the cells. For example, lead acid battery that we use for the cars or any vehicles, and nickel cadmium batteries were used for the gadgets, and then lithium ion batteries that we use daily in our mobile phones and etc., like laptops and mobile phones. So these are the most important applications where there is a scope for charging and discharging. I mean, after during usage, it is discharging, and during again, if we want to use it again, we have to charge. So it has got wide applications. Then what are concentration cells? So same metal is dipped in same electrolyte of two half cells but has different concentrations. So there is a change in concentration of the metal ions that is taking place. So they are called as concentration cells. So what are the differences between electrochemical cell and electrolytic cell? Electrochemical cell, as we have seen previously, chemical energy is converted to electrical energy. Chemical energy is converted to electrical energy. And in electrolytic cell, applying the electrical energy will help in converting into chemical energy. So this is the basic difference between the electrochemical cell and the electrolytic cell. And here the anode is negative electrode and the cathode is positive. And in electrolytic cell, anode is positive and cathode is negative. Okay, then in electrochemical cell, we require a salt bridge for electroneutrality, whereas in electrolytic cell, we doesn't require any salt bridge for the operation. And this is reversible and spontaneous. Electrochemical cell is reversible and spontaneous, whereas in electrolytic cell, it is irreversible and non-spontaneous. Irreversible or non-spontaneous. So the EMF of this cell will be positive in the case of electrochemical cell, and the EMF of the cell in electrolytic cell is negative. So these are the basic differences of electrochemical cell and electrolytic cell. So before we go into the depth of electrochemistry, we have to understand some terms, basic terms of electrochemistry like electrode potential. So this electrode potential is something when a piece of metal is placed in solution containing its own ions, a potential difference occurs. Potential difference occurs between the solution, these are the ions, solution and the electrode or the metal, solution and the metal. So this potential difference is called as electrode potential. So for example, zinc dipped in zinc sulfate, copper dipped in copper sulfate. So copper ions are here, and then there is a copper rod dipped here. So the potential difference between the copper rod and the copper sulfate solution is called as electrode potential. So this is also called as single electrode system, single electrode potential. And this depends on concentration of ions, obviously, because there is the potential difference between the ions and the electrode. So concentration of ions is very important and it depends on that. Then the nature of metal, the electropositivity of the metal, and the temperature of the solution. So the single electrode potential is something like represented something like this, wherein each electrochemical cell is made up of two electrodes. So one electrode, electrons are evolved and the other electrons are consumed. So each electrode dipped in its salt solution is called a half cell. What is a half cell? Each electrode is dipped in its own solution is called as half cell. Then the potential of half cell is called as single electrode potential. Potential of its own electrode is called as single electrode potential. So this is the representation of the half cell. This is the representation of the half cell. So zinc rod dipped in zinc sulfate, copper rod dipped in copper sulfate. This is a half cell. This is a half cell. So these forms half cell and the cell composition. So single electrode potential is defined between the electrode and the solution. Electrode and the solution. So we will go in detail what is a galvanic cell or the electrochemical cell. So it converts the chemical energy into electrical energy. This galvanic cell will convert chemical energy into electrical energy, and it is a spontaneous reaction. Spontaneous reaction. The Gibbs free energy is negative, indicating it's a spontaneous reaction. So we will understand in further slides how this can be understood. And then there are two. This electrochemical cell has two electrodes, zinc electrode and copper electrode dipped in its own solution. So as we see here, it is dipped in its own solutions and connected externally through voltmeter. Connected externally through voltmeter. So this voltmeter will help in measuring the current passing through. So the chemical reaction occurs in this cell. So as we see, chemical reaction will be taking place. It is a spontaneous because it is a spontaneous reaction. So oxidation occurs at one electrode and electrons given out are consumed for reduction at another electrode. So this will help in flow of electrons from anode to cathode. Flow of electrons from anode to cathode, and therefore electricity passes from cathode to anode. Electricity passes from cathode to anode. Electricity. Okay. So we will see in detail how this works, like a galvanic cell or the Daniel cell. It consists of a copper rod dipped in copper solution, copper sulfate solution. Copper rod is dipped and copper rod is dipped in a copper sulfate solution and zinc rod dipped in a zinc sulfate solution. Zinc rod dipped in zinc sulfate solution. So, as we know that zinc has greater tendency for oxidation. So, zinc metal has greater tendency for oxidation when compared to copper. So, therefore, what happens? Oxidation takes place at zinc compartment. So, in this compartment, zinc oxidation takes place and gives off electrons. So, it acts as anode. Oxidation takes place at anode. Then this Zn2 plus goes to the solution, leaving behind two electrons. The evolved electrons will be left there and Zn2 plus will be going into the solution. So the zinc rod therefore achieves negative charge. Zinc rod will achieve negative charge. Then what happens at copper compartment? At copper compartment, these electrons are gained or reduction takes place. Has a greater tendency for reduction. Therefore, the copper will accept these electrons and get reduced and deposit on the copper metal. So this copper acts as cathode. Copper acts as cathode. Cu2 plus 2 electrons gives rise to copper. This copper will deposit on the copper rod. So this is how it occurs. Both the cells are connected through a bend tube. So this bend tube is nothing but a glass bend tube with agar-agar solution that is mixed with KCl, KNO3, either with KCl, any of these, KCl, KNO3, sodium sulfate or ammonium hydroxide that will help in electroneutrality. It means that salt bridge, this is nothing but salt bridge. Salt bridge. We will see the importance of salt bridge next slide. So here these are the reactions that are taking place at anode. So the zinc metal rod is oxidized to Zn2 plus and 2 electrons are given, and at cathode reduction takes place when these 2 electrons are accepted by the copper and forms copper deposited on the metal rod. See, as we see from this picture, copper is excessively deposited on the copper rod and zinc is thinning. Zinc is thinning due to loss of zinc. Due to loss of zinc. So the flow of electrons will be externally from anode to cathode and internally from cathode to anode. So from cathode to anode through salt bridge. From cathode to anode through salt bridge. The flow of electrons is due to difference in electrode potentials of both the electrodes. Difference in electrode potentials of both these electrodes. So this potential difference is called as EMF. This potential difference is called as electromotive force or EMF of the cell and is measured in volts. This is the potential difference measured by voltmeter in volts. So the process will go on, and the transfer of electrons from the zinc anode to zinc cathode leads to accumulation of positive charge around the anode due to zinc plus ions, zinc 2 plus ions, and accumulation of negative ions at cathode due to deposition of copper 2 plus ions or copper cathode. Nothing but, so there is an excess anions at this compartment, excess cations at this compartment. So that will lead to accumulation of ions in both the compartments. So this positive charge that is accumulated, see, as we see here, the positive charge accumulated in this will prevent or omit the flow of electrons from it. So these generated electrons cannot be flowed as due to presence of positive ions here that are accumulated. Similarly, accumulation of negative ions or the anions or the negative ions here will avoid the acceptance of electrons from the anode, and therefore the current will be slowed down and stops. So there is no flow of ions or the electrons through the circuit, and therefore current stops. So what we have to do at this situation? The salt bridge plays a major role. Here the flow of electrons becomes slow. When it becomes slow and due to long time usage, polarization of electrodes takes place and the current stops. So what happens here when the salt bridge is placed? This will help in restoring the electrical neutrality of the solution, that is in two half cells. So when there is an increased concentration of Zn2 plus ions, sufficient amount of anions from this salt bridge. So anions from this salt bridge will migrate into the solution, neutralizing the positive ions or the Zn plus 2 ions in the anode compartment. Similarly, the potassium ions will migrate from the salt bridge. When, for example, when salt bridge, for example, is having KCl, so the potassium ions will migrate into the copper compartment and will compensate the sulfate ions that are present in the cathodic cell and helps in flowing the current or the electrons. So this will maintain the electrical neutrality of two cells in the half cells, two solutions in the half cells. There is another important importance of this salt bridge. It also prevents the intermixing of solutions between these two half cells. Intermixing will be prevented. The solution mixing will be prevented. So what is the representation? How do we represent the galvanic cell? The galvanic cell is represented with an anode and a cathode, oxidation reaction at anode and reduction at cathode. So as per IUPAC convention, the anode is always represented on the left. So this is anode. Anode is always represented on the left and cathode is represented on the right. So this anode half cell, then two slashes, and then cathode half cell. So these two slashes indicates salt bridge. So it indicates that there is a we have placed a salt bridge between these two half cells. Then this Zn rod is dipped in Zn2 plus ions, nothing but copper zinc sulfate solution, and this is the reaction that is going to take place. Like Zn is oxidized to Zn2 plus. So that is why we have written Zn and slash and Zn2 plus. This also indicates that this is a metal, this is a solution. So this is a different state, change of state from a metal to ionic solution. So this is the same thing we are showing here, solid and 1 molar solution or the aqueous solution. Then this is an aqueous solution and this is a metal rod or solid. So these two are separated by a vertical line or a semicolon. So electrolyte can be either can be written in the ionic form or the formula complete form. So these are the basic rules that have to be applied before we write the representation of any electrochemical cell or the galvanic cell. Then what is electrolytic cell? How the function takes place? So in electrolytic cell, electrical energy is converted to chemical energy. Electrical energy is converted to chemical energy, and this is the construction of electrolytic cell, wherein the molten NaCl is taken. Molten NaCl is taken, and inert electrodes are placed. Inert electrodes are placed. So the cell that requires electrical energy causes non-spontaneous redox reactions. So whenever there is an applied voltage or electricity, it indicates that it is a non-spontaneous reaction. It requires some push-up for the reaction to take place. So electrolytic cell contains two inert electrodes. Either can be graphite or platinum, and the electrolyte that is connected through a battery. So the electrical energy is supplied through battery. This is the supply. Okay, the electrode which is connected to negative terminal is called cathode. Negative terminal is called cathode, and the electrode that is connected to positive terminal of the battery is called anode. Positive terminal of the battery is called anode. So what is the working principle of this electrolytic cell? When electricity is passed, so we are connecting the cell to a battery. So the electricity is passed to the cell. So the cations or the sodium ions will migrate towards the cathode. Cations will migrate towards the cathode, and anions or the chloride ions will migrate to the anode. So we can see it clearly in this picture. The chloride ions are moving towards cathode and anode, and cations are moving towards cathode. So this is how the reaction will take place. So when at cathode, what happens at cathode? At cathode, these 2Na plus ions will accept the electrons from the anode compartment and gives rise to 2Na, that is in liquid state. So this is reduction is taking place at cathode. And at anode, the two chloride ions that are migrating to the anode will convert to chlorine gas and two electrons. That is, oxidation is taking place at anode. So chlorine gas is evolved, and the two electrons produced here will migrate to the cathode compartment. So therefore, this is the overall reaction. This is the overall reaction with 2 Na plus ions plus 2 chloride ions will give rise to 2Na liquid state plus chlorine gas evolved. So the total net equation as such, the salt is dissolved in the solution, giving rise to liquid state of NaCl, converting to 2Na plus 2Na in the liquid state plus chlorine gas evolved. Okay. Then what is the standard electrode potential? So electrode potential that is at standard conditions is nothing but standard electrode potential. potential. So what are standard conditions? Standard conditions are nothing but temperature 298 Kelvin at 1 atmospheric pressure and 1 molar concentration. This is nothing. This is called standard electrode potential. It is represented by E naught of the cell. E naught of the cell. So the standard electrode potential will depend on the electropositive nature of the metal. Electropositive nature of the metal. Then what this standard electrode potential? The absolute value of the electrode potential cannot be measured or calculated directly. Cannot be measured or calculated directly. So, for this purpose, we have to consider normal hydrogen electrode or standard hydrogen electrode to be used for determination of this standard electrode potential. So, what is for that we also need to understand what is electromotive force. So, the difference, potential difference between two electrodes of a galvanic cell that causes the flow of current from an electrode from higher reduction potential to a lower reduction potential to an electrode of lower reduction potential is nothing but electromotive force. So it is represented by E cell. It is represented by E cell. So the E cell is calculated like subtracting the potential difference from the cathode to the anode. Subtracting the potential difference of cathode and anode. So what is the significance? What is the significance of this standard electrode potential? This standard electrode potential will help, or this is the difference. This is the main difference of individual potentials of an electrode. So it is measured with the help of a reference electrode called standard hydrogen electrode. Standard hydrogen electrode. So we consider to understand, to determine the potential of a other electrode, we have to consider standard hydrogen electrode to be 0 volts. Standard hydrogen electrodes to be 0 volts. So, good oxidizing agents will have higher standard reduction potentials, whereas good reducing agents will have lower standard reduction potentials. So, for example, in the electrochemical series, if we see the standard electrode potential of calcium is minus 2.87 volts, and the fluorine is plus 2.87 volts. So this indicates when it is fluorine is a good oxidizing agent. Fluorine is good oxidizing agent, and calcium is reducing agent. Calcium is reducing agent. So this is how the electrode potential or the standard electron potential will help us in understanding what is the property of that metal. So how do we determine the standard electrode potential? So this is for example, if we take zinc electrode, if we want to determine the standard electrode potential of zinc, we have to take the help of standard hydrogen electrode. So the setup is like this, wherein zinc rod is dipped in zinc solution, 1 molar zinc sulfate solution, and dipped with a zinc rod, then connected to a standard hydrogen electrode, wherein an inert metal is dipped and 1 molar H plus ions is taken, or any acid, 1 molar acid, and 1 atmospheric pressure gas is sent through the tube, then at temperature of 298 Kelvin. These are standard conditions. What we require are the standard conditions to determine standard electrode potentials. So these are the standard conditions that will form a standard hydrogen electrode. Okay, so with this, at this temperature and pressure conditions, whatever the volts that are produced, the potential that is produced is due to zinc, because we are considering the voltage of standard electrode potential as 0 volts. So it can be measured under standard conditions at 298 Kelvin, 1 atmospheric pressure, and 1 molar concentration of electrolyte. So how does this help in understanding the reactions. So the reactions can be determined before going to any practical applications. We have to understand what reactions are going to be taking place. So for that, we should understand whether it is spontaneous reaction or a non-spontaneous reaction. So the redox reaction, if redox reaction is spontaneous, the Gibbs free energy must have negative value. Gibbs free energy should be negative value. So what is Gibbs free energy? How is it described? Delta G cell, G naught cell is equal to minus NFE E naught cell minus NFE E naught cell, where N is the total number of moles of electrons. Then for every mole of product that is formed, then F is nothing but Faraday's constant, as we all know, 96485 coulombs per mole. Then E naught can be obtained with the help of this following equation. So E naught cell is equal to E naught cathode minus E naught anode. E naught cathode minus E naught anode. Therefore, E naught can be obtained by subtracting standard electrode potential of anode from cathode. Okay. So for a redox reaction, spontaneous redox reaction, E naught must be negative. So E naught cell must be negative. And so when we substitute on that equation, both N and F values have positive values and delta G will become negative. So therefore it gives spontaneity of the reaction, that indicating it is spontaneous redox reaction. So spontaneous redox reaction. When E naught cell is greater than 1, when E naught cell is greater than M, which again implies that E cathode is greater than E anode, which implies that E cathode is greater than E anode, then only it will be a positive value and the giving rise to negative Gibbs free energy, indicating spontaneous reaction. So thus, electrode potential or the standard electrode potential of the cathode and anode will help in predicting the spontaneity of the cell reaction. So it can be noted that G naught cell is negative. If G naught cell is negative, it is in the galvanic cell, indicating spontaneous reaction, and if it is positive, it is non-spontaneous in electrolytic cells. In galvanic cell, spontaneous reaction takes place, and in electrolytic cells, non-spontaneous reactions takes place. So this is how the reactions can be predicted and can be observed and can be planned for further applications. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.